Alright, so yesterday we talked about our first two transformations, which were our amplitude and the period. Today we're going to talk about our last two transformations, which are our phase shifts. There are two different types. There is a vertical or horizontal translation. So basically now we're moving left and right and up and down instead of like stretching or compressing it. So hopefully we recall from yesterday, what were our two variables that we got? A and B. Today we're getting C and D. So your C value is on the inside of your trig function. Your D value is on the outside. Now for your vertical shift, it's going to be up or down D units. So whatever number D is, that's how much we're going to go up or down. Now for your horizontal shift, it's a little different because it's on the inside. And what else is on the inside of our trig function? B. So B is going to affect it as well. So we're going to go left or right. C over B units. And we'll look at why that's the case in just a bit. So when we look at our graphs, what do we want to start by doing? What did we start by doing yesterday?
Our unit.
Before that?
Find our amp.
Yeah, so we want to find the different things, right? So we said we want to label our different characteristics before we even start trying to graph it. Because once we get all of those things labeled, it's much easier then to use all that stuff to graph it. Okay? So here we have y equals 1/2 times sine of x minus pi over 3. Now, is pi over 3 a C value or a D value?
C.
How do I know? Because it's inside, because we have parentheses. So what is our amplitude going to be? 1. What is the period going to be? 2 pi divided by 1, so we just get 2 pi. Alright, and so the next we want to look at the horizontal shift. Now, the easiest way to look at that, okay, so shifting left or right, okay, again, is based off the stuff on the inside, yes? So, where do we normally start our first cycle of our graph?
0.
0 is where we normally start it. So what we're going to do is we're going to take whatever is on the inside and we're going to set it equal to 0 because then that will give us our new starting spot. You with me? So if I solve for x, what do we get? It's pi over 3. So because it's positive, that means that we've moved to the right. And we've specifically moved to the right by pi over 3. Do we have a vertical shift? No. So we said that our starting for our first cycle is going to be pi over 3. How do I figure out where my first cycle is going to end? Is it going to be 2 pi this time? Why not? Correct. So how do I figure out where my ending is?
You have 2 pi to the x.
Which x?
The pi over 3.
Yeah. So wherever we're starting, so for us, yes, is pi over 3. We're going to add the period, which in this case is 2 pi. So we're going to take pi over 3 and add 2 pi. So what would we do? So what's our common denominator? 3. So we get 6 pi over 3, which gives us 7 pi over 3. So that's going to be our ending spot. And the reason that we want to find that stuff first is because it's going to allow us to label our units easier. Yes?
Wait, so to find the end, you just take the start.
So this was our starting spot. And then I added
Okay.
the period of the graph, which in this case was 2 pi. But if it was something else, then we would add whatever that was. Yes?
If you wanted to extend it to the left of the y-axis, would you subtract 2 pi from the pi over 3?
Correct. Or if you wanted to find out if I had a second one, then I would add 2 pi again.
Okay.
But either way, yes. Good question. So even though our x values have changed, is the pattern still the same of our graph? Yes. So what does our sign start at? It starts at a 0, but this time instead of starting at 0, 0, it's going to start at what?
Pi over 3, 0.
Pi over 3, 0. So what might be a good unit for me to go by on my graph? Pi's over 3's would probably be helpful. So this would be 2 pi over 3, 3 pi over 3 would give me pi, 4 pi, 5 pi, 6 pi would be 2 pi, and then my last line would be 7 pi. So we said we're starting at pi over 3, 0. Excuse me. So then what are we ending at?
7 pi over 3, 0.
Yep. So remember we have to start and stop at the same y value. So then what's going to be halfway in between?
Also 0.
Also a 0. And what's it specifically going to be at? What x value?
1 pi over 3. Wait. It'd be 4 pi over 3.
Agreed. How did we get that?
You just add a pi to pi over 3.
Halfway between.
So if we were counting by pi's over 3, yeah, pi over 3, 2 pi, 3 pi, 4 pi, or it would be halfway in between. So how do I find halfway in between?
Like 7 pi over 3 by 2.
Not quite. You do divide by 2, but you gotta do something
8
first.
pi over 3 divided by 2.
It would be 8 pi. Where'd you get 8 pi from?
Because you add pi, 3, and 7.
Yeah, so you add together whatever you're trying to find the middle of. So pi over 3 plus 7 pi over 3 gives us 8 pi over 3, and then divide by 2 gives us 4 pi over 3. So then what's in between my first two zeros? Our max. No, our first two is just our max, right? So then what is our maximum going to be at?
Half.
Just a half, because our amplitude was changed this time. And then what's in between my second two zeros? Your minimum, which is going to be at -1/2. And then we draw a nice pretty curve. Questions on how we got any of those numbers? Because the process is going to be just as important as your final graph. Because remember, I could ask you, just find the amplitude. Or just, what is the horizontal phase shift? Yes? So we still need to know how to find all the different pieces, not just the overall graph. Questions so far? Alright, let's look at another one. What's different about this one?
It's cosine.
This cosine? What else?
There's a b.
There's a b value this time. So remember we said that that b value is going to affect the c value as well.
Wait, how do we know which one to start on? Like 0 or the max or
Depending on what it is. Sine always starts at a 0. Cosine starts at a max. So, first off, let's label our amplitude. What is our amplitude?
3.
3. Why is it not -3? Because it's the absolute value. Okay, but what's that negative going to do? What do you mean by direction? Flips it, or is a reflection. So that's not going to change the amplitude, but we do probably want to make a note that this will be a reflection. So for cosine, we normally start at a, which is the maximum, right? And so this time we're going to start at the minimum instead. Does that make sense? So then, do we have a different period this time? Yes. So, what is our b value this time? 2 pi, yes? So 2 pi divided by 2 pi just gives us 1. It's a nice number. So then next, do we have a horizontal shift?
Yes.
Yeah.
Yeah.
4 pi.
Be careful. Because your C value, yes, is the 4 pi part. However, our shift, remember, is not just the C value. It's going to be C divided by B. So if, again, remember we said the easiest way to figure out what your shift is to take the stuff on the inside and set it equal to what?
0.
0. So then what would we do to solve? How do we get rid of the 4 pi? Subtract. And then,
Divide both sides by 3 pi.
so we get
2.
negative 2. So what does the negative tell us? We've gone to the left 2 units. Now, do we have a vertical shift this time? Nope. Now, where will our starting spot be? We just found it. Where are we going to start?
Negative 2.
-2. And then how do we find the ending spot? So -2 plus 1 gives us -1. So I'm going to go by a unit of 1/2 this time on my x-axis. So we said normally cosine starts at a maximum, agreed? But because we've reflected it, we said we're going to start at a minimum. And we're specifically going to start at -2. So 1, 2. And what is our minimum value going to be at? -3. So we would be here. And remember, we have to start and stop at what? The same y value. So since I'm going to stop at -1, I have to have the same y value at -1. So that's going to be -3 as well. So then what's halfway in between those?
-3.
Not quite.
-2.5.
Not quite.
I don't even know.
Your maximum, and what x value is that going to be at? So this is -1. So it would be -1.5. Okay, and then what's our y value going to be? 3. And then halfway in between each of those, we have our zeros. So that would be one cycle of that graph. Questions on yes.
How would I find 1.5?
Here?
Yeah.
So again, this is at -1. This is at -2, right? So I would add them together, which would be -3. Divide by 2, I get -3/2, which is -1.5. You're just looking for what's halfway in between. Because remember, our 4 key points are in quarters, right? Because we're using our quadrant angles. So I know that that one in the middle is going to be exactly in the middle of my 2 endpoints. And that's why it's nice to use those quadrant points, because they're going to be in that same pattern and they're going to be halfway in between each other. Other questions? So lastly, we're going to look at one with our d value, which to me, your d value is actually easier to graph is stuff with your C value. Your C value is your hardest one to graph. Okay. So what is our amplitude this time? 3. What is the period this time? 2 pi divided by 2, which gives us just pi. Okay. Do we have a horizontal shift this time? How do I know that the 2 is outside of my function? There's no parentheses, and it's coming first this time. So a lot of times in your book, they're going to write that 2 first. If you wrote it behind it, that's fine. Just remember, you can either just put parentheses around the 2x, or if we don't put parentheses, then it's also understood to be on the outside. But that's why your book likes to do it in front, because then it's really easy to see that it's not. So what would my equation be if I wanted it to be a negative 2?
It'd be -2 plus.
It would still be plus, so it would be -2 plus 3. If I had a -2 minus 3, that would cause us to have a reflection as well. Okay, so remember that addition sign in between doesn't give us the sign, S-I-G-N, of the vertical shift. So what is our vertical shift? Up 2. So at what x value are we going to start our first cycle? 0, because we didn't move it left or right any. Where are we going to end?
Pi.
Pi. We take our starting spot, add our period, and we get pi. So I'm going to go, let's say our pi is over 2. And then I'm just going to go by 1s on my y-axis. So the easiest way to do your d value, okay, we've shifted everything up 2. So I'm going to draw an imaginary dotted line at y equals 2. And then what we're going to do is we're going to treat that imaginary line as our new x-axis. Because if we treat it as our new x-axis, then basically all of the other stuff is going to stay the same. So we said we're starting at 0. We have a cosine graph. What does cosine start at?
Max.
It's maximum, okay? So our amplitude is what this time? 3. So our maximum is going to be 3 units above our new. Yes, so we would be at 5. Okay. Which means, what do we have to end at? 5 as well, and it's going to be at pi. Halfway in between, what are we going to have?
0.
Not a 0. The minimum. And it's going to be 3 units below our new x-axis, so we're actually at -1. And then halfway in between each of those are our zeros, but this time, like I said, our zeros are actually crossing that y equals 2 line. And then we just make a nice pretty curve. So that's why I said, really, as long as you just draw your new line, the d value is pretty straightforward. The c one is the one that gets a little bit odd, just because you have to add and divide by things. But, alright, questions on any of that stuff? Those are all 4 of our transformations for sine and cosine.